Hi, in this version of the problem, we are going to be looking at using divergence alternating summation or integral tests to determine whether or not a series converges or diverges. So let's take a look at our two series. We note that the very first series is a rational expression, uh, 3n to the fourth plus 3n cubed 4 over 2n to the fourth plus 5n cubed plus 1. And what we should note is that this is a rational expression where both the numerator and the denominator have the same degree. And terms like that, or rational expressions like that, converge when we take their limit to infinity. So what we note is that, note, the limit as n goes to infinity of our rational expression this will actually converge to 3/2. We can do this by comparing the leading terms of irrational expressions or by taking L'Hopital's rule. But we get that this is 3/2, which is very much not 0. Now, the summons conversion to 0 is a prerequisite to a series converging. That's what the divergence test says. What this series does instead, in the long term, is essentially add 3/2 to itself repeatedly, and something like that could never converge. So, by the divergence test, this series diverges. The second of these problems asks us to consider the series n goes from 1 to infinity of 1 over n to the 1/4. And this expression is the quartic root of n. So we note that as n increases, n to the 1/4 also increases. It increases in an unbounded manner, and thus the summons themselves converge to 0. So we can't use the divergence test to just rule out that it diverges. However, we can note that this looks very much like an integral expression we have seen before. So note, if I take the indefinite integral from 1 to infinity of 1 over n to the 1/4 with respect to n, this diverges since 1/4 is less than or equal to 1. Thus, by the integral test, the corresponding integral diverges, which means that the summation diverges as well. All right, last part of this is the third sequence, the sum from n equals 1 to infinity of minus 1 to the n over 2n. And the first thing we want to note is that this is a alternating series. When n is positive, these expressions are negative. When n is negative, these expressions are, or the summons are positive. So it's the sum of a negative with a positive, with a negative, with a positive, and we're looking at that sequence here. So, since, and we can take a look at the limit as n goes to infinity of the summons without the alternating, or the absolute value of the summons, 1 over 2n, we get that limit is 0. So that tells us first two things. One, because it's an alternating series, the terms of the summands themselves range from positive, negative terms, both convergent to 0, so it does not activate the divergence test. More importantly, because these are alternating sums convergent to 0, by the alternating summation test, the series itself converges. So by the alternating summation test, this series converges. And we are not asked to find what it converges to. All right, thank you very much. I will see you in the next video.